Okay, so the square root of 5 times square root of 10, when we multiply that square root of 50 is not perfect square. So you can do it that way. You could go square root of 50 and a perfect square out of that is square root of 25. So we'll do 25 times 2. Square root of 25 is 5. And we'll leave the square root of 2. We'll leave the 2 under the radical. That's one way. Or you could do square root of 5 and then say 10 is 5 times 2. I'll just do another square root here. This square root of 5 times square root of 5 is square root of 25. So that would be 5. So you can do it either way. Whichever way makes more sense to you, and that's the way you do it. Okay, let's do one. Square root of 3x, square root of 12y. That means square root of 36xy, right? Okay, this is the only part you can do, right? Square root of 36. That's 6. You have to leave the xy under the radical. Alrighty. How about the square root of y minus 2? I put it in parentheses, but in the book you have some that don't have the parentheses. It's just y minus 2, square root of y minus 2, square root of y minus 2. What is it? Y minus 2. Just like the square root of 5 times square root of 5. That was the square root of 25 is just 5. So when you see a square root times itself, it's just going to be itself. It'll be what the radicand was, under the radical. It'll be the 5. So this is just y minus 2.
Like the same where there's a 3 outside, it has to have like 3 in the same.
The 3 on the outside?
Yeah, like there's a guy around.
Oh, the Eric's one would be a 3 on the.
Is it like the same way?
It's similar.
Oh, okay.
Yeah, it's similar.
Look. Is it? Okay. Okay.
Explain what you guys are talking about. I have no idea.
You see where
Are
the
you-
square root's at for y minus 2?
Like if it had a 3 out here?
No, on the outside where the square root's at.
Oh, the cube root.
Yeah, the cube root.
Okay, if it had a cube root right here?
You would have to group them in 3 and that would be the
Right. If you had 3 of these, then your answer would be y minus 2. It means what times itself 3 times will give you this. Like, let me do the cube root
Do we have one of those?
of 8. You're going to have, you might have a cube
of
root.
27 is 3.
The cube root of 8, what times itself?
2.
3 times is 8. That's the 2, right.
Do we have any of those on the?
Not on this section.
I was just trying to comprehend
Yeah.
how you get the 5. Like how you have to group them.
Yeah.
Like how,
All right.
Same thing.
Rein in that horse, Raymond. Rein in that horse.
Okay, we're going to go ahead and go to 8.3. We're doing quotients that involve radicals. Okay, that means that you have a quotient which is divided. If you have like square root of 25 over square root of 16,
5/4.
5 over 4, right. Okay, sometimes you'll have a number where the bottom does not totally come out perfect. You end up with a square root left in the bottom. And when you have one like that, like you have square root of 4/3. Okay, you would do square root of 4 over square root of 3. So that would be 2 over square root of 3 does not come out right. Okay, it is not nice to leave a radical in the bottom, in the denominator, okay? It's kind of like we never divide by 0, or like, more like in fractions you simplify, okay? It's just like proper English, it's proper to always reduce. It's proper to get that square root out of the bottom.
So that's radical, that's not
A
supposed to
radical, you do not
That's
want to
what-
leave it in the bottom.
Okay.
So what we want to do is we want to figure out how we can change it into a number that does not have a radical. Remember, when you multiply it times itself, you get times the same radical, you can take it out of the radical sign. Like square root of 5 times square root of 5 was 5. Okay, if we could multiply it where this is multiplied by square root of 3, it'll turn into a 3. But without changing a fraction, you don't want to change the value of it. You want to multiply it by 1. So if you multiply the bottom by square root of 3, you need to multiply the top by square root of 3 also, right? This is called rationalizing the denominator. It's rationalizing it.
Rational about that, man.
It's not radical anymore, it's rational. Like some of you are radical. If you were rational, you would be a lot calmer, right? We're calming down the denominator. Okay, square root of 3 times square root of 3 is just a 3. 2 times square root of 3 cannot be simplified, you just leave it just like it is. So that's what you would have to do to rationalize that denominator. If we have square root of 5 over 18. Okay, the 18, we can see that there's a perfect square in there somewhere, right?
9 and 2.
9 times 9 and 2. Okay, so we're going to leave the square root of 5 on top. The bottom we're going to turn into square root of 9 times square root of 2, which turns into, what does the bottom turn into? 3 times the square root of 2. Okay, we don't need to multiply it by the 3 part, but we need to multiply it by the square root part. So the top and bottom, we need to multiply by square root of 2. So that turns this part right here into 2, right? So we have 3 times 2. 3 times 2 is 6, and we have square root of 5 times square root of 2, square root of 10. Will that reduce into anything? No, it will not divide. So you have the square root of 10 over 6, and that's as far as you can reduce that. Okay, so you're gonna have, let's do some like with fractions with variables in them. Give you some of that stuff. We'll go square root of y squared over 20. Okay, the top part,
Y.
just y. And the bottom, does 20 have a perfect square in it?
4.
4, yeah. So to be square root of 4 times square root of 5, the 4 turns into 2. So you got 2 times square root of 5.
Over Y.